Okay, welcome back. Once again, I am welcoming you all to this beautiful online learning platform, Unacademy. Unacademy is the India's largest online learning platform. Now we are happy to announce that Unacademy is going to providing online training for GATE and engineering service examinations with India's best educators. Okay, and experienced faculty, top experienced faculty. Okay, with the combination of this, they are going to providing best training for GATE and engineering service examinations. Now, about myself, I G Venkata. I have 16 plus years of teaching experience. So far, I mentored more than 60,000 students for their GATE examination. And at present, I am pursuing PhD from JNTU Kakinada. And my specialization is VLSI design. Now, see this. First, we check how to get Unacademy learning app into our device. Now, just go to Play Store in your device, type Unacademy. Then it will install the Unacademy learning app. It will show the Unacademy learning app like this. Just by clicking on this install button, it will install the Unacademy learning app into your device. Now, see what you will get by joining in Unacademy. See, daily live classes you are going to getting. This is the first benefit you are going to getting. Okay, so chat with your educator. Chat with your educator means chat with your faculty. Engage in discussions. Ask the questions. Ask your doubts. Engage with the faculty and discuss with them. And answer the polls. During the classes going on, faculty will ask some polls. So answer those polls. Okay. So you can perform all these things while class is going on. Next, structured courses. Your course is well structured for the exam what you are going to be writing. Okay, whatever the syllabus you have for that exam, that syllabus is structured well. Okay, and live tests and quizzes. Okay, so you have to write more number of examinations, more number of tests you have to be attempt. Okay, then only you can easily write the final examination. Okay, so there are plenty of live tests are going to be conducted and quizzes also conducted just to evaluate whatever your preparation. Okay, so after your preparation, to evaluate your performance, we are going to be conducting these tests and quizzes regularly, and detailed analysis after that we are providing to you on your performance. Based on that, you get some idea on where you are, how much preparation you done, is it sufficient or not, is there much anything is required, anything is missing. So you can get all that information. And after that, unlimited access. See, once you joined in any one of the subscription, once you take in a subscription, you can access that video, that recorded session and live sessions number of times, unlimited number of times. Okay, and with your comfort device, you can go for either laptop, mobile, tab or desktop, whatever it is as you wish. Okay, in any device you can get that. For example, now today I have a live session at home. There is a power issue or a network issue. I am unable to attend that. Next, immediately after completion of session, also by tomorrow or today evening also, when all the things are available properly, then you can get that recorded session. You can listen that class number of times. Okay, during your preparation, if you have any doubt, you go back and listen that topic once again. That facility is available here. Okay, so here is tests and quizzes you are writing. Now there are two subscriptions. First one is iconic subscription. Okay, here we are take your GATE and engineering service exam preparation to the next level with personal coach. We are providing a personal coach to you in this. So in this personal coach, what is the meaning of personal coach? You are asking, sir, we are not playing any cricket, why are you providing personal coach? Yeah, there is a requirement for coach in everything, every field, coach requirement should be there. What is that coach? What he is doing? So we are providing for proper guidance, one-to-one guidance. So get one-on-one guidance. For every student we are providing a personal coach for guidance. From they are going to be the top exam experts. Top exam experts we are providing as a coach to you. Okay, he will, based on the exams what you are writing, he will analyze that exam and they will mention the what is your strength, what is your weakness. Okay, and based on those things they will prepare proper preparation strategy and learning resources. That means proper preparation strategy, that is a proper study plan, how to prepare, what is the plan for you, what is this today's topic, what is your today's topic, what you have to do, what is today's topic and how you have to prepare and respect to material and respect to video source. Okay, recording session, everything they will provide, and study tracker. So here we are going to track your plan and study booster workshops. We are tracking your preparation and your performance by continuously by providing a proper study planner and study booster workshops to you. Okay, and evaluating your performance by weekly reviews with personal coach. Okay, and examinations. So strengthen your mains answer writing through regular practice with evaluation and personalized feedback. So write more number of examinations. Okay, and practice more, evaluate and personalized feedback. So once you are writing exam means you are going to getting a feedback, personalized feedback from your personal coach. So write the more now, attempt more number of examinations, get the more amount of feedback. So feedback means, see, you observed or not, see, that to that feedback we are providing positive as well as negative. Positive means where you are strong we mention, but we highlight on only negative mostly. Why? Because even by giving negative feedback only your amplifier is getting stabilized. That is the power of negative feedback. Okay, don't criticize others. Once someone given some negative, highlighted some negative point in you, once they told you some negative point in you, okay, please don't criticize them. So take it as a positive and be strengthened in that region. Okay, that is very important. And after that, all benefits of class. So the benefits you are getting is live classes from top educators you are getting, mock tests and quizzes you are going to writing, structured both courses in line with exam syllabus. All are structured in a line, a proper way for your exam syllabus. This is about your iconic subscription. And next, plus subscription. For plus subscription, this is the basic subscription. So daily live classes are there. So in that you can chat with your educator, engage in discussions, ask your doubts and answer the polls. Okay, so you can do all these things while class is going on, and the structured course is there. So whatever the courses you have, all the courses are going to be structured effectively with your exam syllabus. Okay, and live tests and quizzes. So to evaluate your preparation with our regular mock tests, whatever the thing you prepared by writing the examination, evaluate your performance, where you are, analyze your performance. If required, you need to enhance your preparation. That means you are going to identifying your gaps in your preparation by writing number of tests. Ultimate access. See, you can use your recorded sessions and live sessions number of times. If you are unable to attend live session, you can use the recorded session. And recorded sessions you can use number of times. Whatever the device comfort for you. Okay. Now, our today's topic is transistor biasing, in that operating point and its stabilization. Okay, this is our today's topic. Now, first, what we are going to discussing in this. First, I am going to operating point. Operating point. Okay, now see this. What is operating point? See, it is nothing but the point in active region where your transistor is operating. It is a point in active region where our transistor is operating. So it is a point in active region where transistor is operating. Okay, it is a point in active region where transistor is operating. So now you need a point, therefore we need a point in active region. So therefore we need a point in active region. So we need a point in active region. So we need only one point that should be in active region. Now I am going to take you. See this. Here I am going to drawing the default configuration we are taking is a CE configuration is the default configuration. CE configuration is the default configuration, CE mode. Now I am taking CE output characteristics. Output characteristics. So in general, in CE mode, your transistor is placed like this: emitter towards ground side, collector at output side, and base at input side. Emitter towards ground side. Now operating point means, so here it is collector current, and there is a voltage between collector to emitter, VCE. This point VCE comma IC is called operating point. Therefore operating point is VCE comma IC. VCE comma IC. This is the operating point, and our operating point also called as quiescent operating point. quiescent operating point. Quiescent operating point, or operating point also called as quiescent operating point. Quiescent in this sense, quiescent is nothing but a without input signal. Without input signal. So without applying any input signal, whatever the value of VCE and IC value, that is called operating point. Okay, and generally we call it as Q point. Q point. Q point. Okay, now that point should be in active region. Now I am taking CE output characteristics. In that I am going to representing that. See this? This is IC and this is VCE, output voltage, VCE. Now should be, this is the CE output characteristics. Here transistor is operating in CE mode. Now the output plot is like this. This is the plot for IB 0, IB equal to 0 microamperes, and this is the plot for this is the plot for IB equals to IB minimum. So that means this is the minimum base current required to take your transistor from active region to saturation region. Now so I am copying this for future reference. Now see this, here this is active region, we know that, and this is a saturation region, it is cutoff region. So we need to operate transistor in this active region, and now our intention is to fix a point, that means to identify a point in active region. See this, it is a operating point, means it is a point in active region where transistor is operating, and we need a point in active region. So we need only one point in active region. See this, how many ways we can place a point on this. See, you can take a point here, 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 anywhere in this active region you can take a point. So there are infinite possibilities, infinite possibilities. So therefore there are infinite points you can place in active region. Okay, but we need only one point. Which point you have to be select? That is our problem now. Okay, so here, so first one is, so there are infinite points, there are infinite possibilities, so infinite points. Okay, infinite points, there are infinite points, can place in active region. So here, but we need only one point. But we need only one point. But we need only one point. So which point I want to take? Which point we have to take? Which point it is? It is. That is our doubt. So now here is we have a problem. Here is our problem. We have a problem here. Which point we have to be take? Okay, which point you have to take in that? So to solve that problem, we are taking the help of DC load line. Okay, so to identify that problem, we need to take the help of, so to identify the problem, to identify the required point in active region, taking the help of DC load line. DC load line. Now this is a new point. DC load line. This is the new concept. DC load line. What is this DC load line? First you should know that. So DC load line is a line joining the cutoff and saturating points. A line joining the cutoff and saturating points. So just a minute. So I am defining the DC load line here. DC load line. So it is a line joining the cutoff and saturating points. A line joining the cutoff and saturating points. Now what is that cutoff point? What is the saturating point? See this, a point in saturation region is called saturating point. So this is the IB minimum. That means we define this IB minimum is the minimum base current required to take your transistor from active region to saturation region. So that means this is going to be the maximum IC. So maximum IC maximum. Now this point is called saturating point. A point in saturation region. Hitting point. And this is the a point here somewhere, and where I am going to getting the maximum VCE. Maximum VCE. Here I am going to getting maximum VCE. VCE maximum. And this point is called cutoff point. cutoff point. This point is called cutoff point. Okay, now DC load line is line joining this saturating point and cutoff point. So now I am going to draw that. So now this is the DC load line. Now this is our DC load line. So DC load line. So far we know what is DC load line, what is cutoff point, what is saturating point. A cutoff point is a point where you are getting maximum value of VCE, and saturating point is a point where you are getting maximum IC. Okay, and the line joining this cutoff and saturating point is called DC load line. DC load line. So once you define DC load line, now our operating point is first in active region and on DC load line. Now I am writing that. Therefore, now operating point should be first one in active region, second one and on DC load line. DC load line. So now operating point should be in active region and on DC load line. Now for reference purpose I am taking once again, I am going to plotting that for better understanding. So these are the values. So this is our VCE and it is IC. So these are the plots what we get. Okay, now this is for IB minimum, IB equals to IB minimum, and this is IB equals to 0 microamperes. And at the same time already we plotted its DC load line. Now this is the DC load line what we plot. DC load line. This is the DC load line. Now what you are saying is operating point should be in active region and on DC load line. That means now it is from this point to this point. In between these 2 points, your operating point. So now you can take any point on this. In between these 2 points, you can take any point that is going to be the operating point, like this. Again, there are infinite possibilities. Infinite points you can take. But here we need only 1 point. Okay. So what is that point? So we need to identify that. To identify that point, what we have to do is see this, we need only 1 point. For that I am taking the help of DC load line. For that I am taking the help of DC load line. Sorry, DC load line we taken. Now for that, to solve this problem on DC load line, you can place infinite possibilities, infinite points you can place it. So to solve that problem, I am taking the help of characteristic curve. That means with IB 0 microamperes we plot it. Okay, similarly IB minimum you plot it. Now between IB 0 to IB minimum we have so many number of base currents, IB1, IB2, IB3, like that. Okay, now they are the characteristic curves. Okay, now I am taking the help of that. So here our problem is, so therefore here we can place infinite points on, you can place infinite points on DC load line in active region. Therefore we can place infinite points on DC load line in active region and inactive region. But here we need only 1 point. But we need only 1 point. So for that I am going to taking the help of, therefore taking the help of characteristic curve. Taking the help of characteristic curve. Taking the help of characteristic curve. Now I am going to doing that. So now I am going to plot it with the different characteristic curves. This is IC, it is VCE, IC VCE, and these are the plots. So these are the regular plots what we have. Now with the different base currents I am going to plot it. With IB1, IB2 and IB3. Okay, these are the different plots. Now okay, here IB is equal to IB minimum. This is for IB equals to IB3. This is for IB equals to IB2. And here is IB equals to IB1. And this is IB equals to 0 microamperes. 0 microamperes. Now this is the operating point. This is the saturating point where I am getting maximum IC, and this is the, let us take where we are getting maximum VCE. Okay, maximum VCE. Now I am going to plot this DC load line. Yeah, this is the DC load line. Now, here are the intersecting points. This is one of the intersecting point, and this is another one, another one, another one, and another one. Here I am not going to giving priority, we are not giving priority to this point and this point, because this is saturation region, this is cutoff region. This operating point is, if I take this is the operating point, it is the edge of the saturation region. So because of that I am not giving priority to this. Similarly, it is at edge of the cutoff region. That's why I am not giving priority to this. Now I am taking operating point is either this one, or this one. Once you take in the characteristic curve, now operating point is, see this. Now these are the my conditions. Now operating point is first inactive region, second on DC load line, third and on characteristic curve. So DC load line characteristic curve means it is the intersecting point. Should be intersecting point. Should be intersecting point. Point of DC load line and characteristic curve. And characteristic curve. Now, so either this one, or this one. Now let us, I am giving some name to this Q1, quiescent operating point Q1, quiescent operating point Q2, and quiescent operating point Q3. So these are the 3 points. See, now our problem is reduced from infinite possibilities to now only we have 3 possibilities here. Now our problem is reduced from infinite to only 3, either Q1, Q2 or Q3. Okay, now, but we need only 1 point. So now, therefore now we have 3 options, we have 3 possibilities. Okay, now we check the 3 possibilities. Just a minute, I'm taking some space. So B1 microamperes. So this is microamperes. So okay, IB minimum, IB3, IB2, IB1 0 microamperes. This is VCE. VCE. Okay. Now I am taking the copy of this for reference purpose. So now in this Q1, Q2 and Q3, you need to select which one is the best one. That is our intention. Okay, just we need to select which one is the best one in this. That is our intention now. Okay, so for better reference, better understanding, I am going to removing this portion. Sorry. Yeah. See this? Now this is our plot. This is for IB minimum. This is for IB1, IB3, IB2, IB1, IB0. Now from this plot, from this what we are observing is, this is the IC maximum. Whatever the input signal you can take, your collector current cannot cross this IC maximum. And this is the meaning of IB minimum. It means your collector current is not less than this. Okay, so whatever the input signal you are taking, your signal value, current value is not going to vary this. If I am trying to increasing the input signal, at that time your collector current is increasing up to this point. After this it cannot increase beyond this. Okay, similarly you are decreasing input signal, you are decreasing input signal decreasing, but it will reach up to this minimum value. Less than this it can't. Okay, so possible maximum I see in this sense, your output voltage is going to be, output signal is going to be restricted by IC maximum and IC minimum. Okay, now I am going to taking Q1 is the operating point. I am trying to take Q1 is the operating point. In that case what happens? See, and one more for reference purpose I am taking the copying this plot. Now here I am going to taking Q1 is the operating point. Okay, now this is the Q1. Now this is the line. You are getting like this Q1. So this is the line for Q1. If you are taking this is the operating point, let us I am going to increasing the input signal. So once you are increasing the input signal, with respect to applied input signal, you are expecting the current of this much. You are expecting output current has to increase like this, and negative direction also it should move like this. This is the thing you expected. This is the expected one. But due to the limitation of IC maximum, due to the limitation of IC, your collector current cannot cross this point. So your current is going to be limited up to this point. This is IC maximum. Now this portion is going to be clipped off. You are not getting this one. Not getting this. Okay, now so here what we observed, negative positive portion of the output signal is clipped off. Positive portion of output signal is clipped off due to limitation on IC maximum. Okay, now if I take Q1 is the operating point, positive portion of the output is clipped off due to limitation on IC maximum. Therefore, if Q1 is taken as operating point, if Q1 was taken as Q1 is taken as operating point, so then what happened? So the positive portion of the or positive excursion of the output signal is limited. The positive excursion of the movement or excursion of the positive excursion of the output signal is limited due to IC maximum. So that is the drawback in this. Therefore, positive portion is clipped off. Therefore, see, negative direction you can increase, no problem. Therefore, positive portion is clipped off. It's clipped off. So from this, because of some portion is clipping off and some limitation in one particular direction, I am not going to choose Q1 is the operating point. So I am not giving priority to this Q1. Okay. So next, I am going to take Q3 is the operating point. Let us, for Q3 operating point, first I am taking, this is IC maximum and this is IC minimum. And this is the operating point. Here I am taking operating point. Q2 it is. Sorry, Q3. Okay. Now, similar to previous case, in positive direction you can increase the signal any value, no problem. But in negative direction there is a limitation. So you can't reduce the input signal much like this. This is the expected one. But Here positive side you can increase, it's not an issue, but in negative side there is this portion is clipped off because of IC minimum. This is IC minimum and this is IC maximum, we know that. So the portion in negative direction is clipping off. So there is a limited movement or excursion of the signal in negative direction. So if Q3 is taken as operating point, Q3 is taken as operating point, then the negative movement of the output signal, negative direction or movement, negative movement or excursion of the signal of the output signal is limited due to IC minimum, is limited due to IC minimum. So that is the problem in this. Therefore negative portion is clipped off. Negative portion of the output is clipped off. So this is the problem. So because of this, Q3 is not taken as operating point. Therefore Q3 is not taken as operating point. Q3 is not selected. So because of this, Q3 is not selecting, and because of this, Q1 is not selecting. So automatically remaining is Q2. It is the midpoint of the active region and midpoint of DC load line. Okay, now I am going to verifying that. Is it possible to select that one or not? Is there any chance to give priority to that one or not? Okay. Now this is the IC maximum line and this is the IC minimum line and this is the Q2 operating point line. It is observed or not approximately midpoint of this, midpoint between IC maximum and IC minimum. IC minimum. It is the midpoint of this IC maximum and IC minimum. So if you take this is the operating point, now there is a equal chance to get positive portion as well as negative portion. Symmetrical signal is possible to get at output. Okay. See, you may ask one thing, sir, in this case you are getting clipping. See, in this case also we are getting clipping, but once you are getting clipping at positive end, automatically negative end also is going to be clipping. Okay, both these sides it is going to be clipping. Okay, so but previous case only one side. So that means output signal is not symmetrical in previous case, but in this case output signal is symmetrical. Okay, so therefore by taking Q2 as the operating point, point. At output, we get symmetrical signal. Symmetrical signal. Okay, symmetrical signal. So no clipping. If you control the input, then there is no clipping. So here positive excursion and negative excursion is equal moment. Because of that only we are getting a symmetrical signal. So from this I am concluding that therefore Q2 is taken as the operating point. Therefore Q2 is taken as operating point. So far we know what is operating point, and the operating point is at midpoint of the DC load line and active region. Okay, so operating point is at midpoint of the DC load line and in active region. This is the operating point. Just so far we fix the operating point. We fix the operating point. After that, once you fix the operating point, you need to take care about stabilization of that operating point. Now we go and discuss about that. So this. So far, we fix the operating point. Operating point. Now, need to stabilize that operating point. Stabilize that operating point. Need to stabilize that operating point. That is our intention. We need to maintain that operating point stably at that point. Okay, so now I am going to the topic. So that is a stabilization of operating point. Stabilization of operating point. Okay, now here how to stabilize the operating point. Of sorry. So stabilization of operating point. Now we are going to how to stabilize the operating point. Okay, now see in that output plot it is IC and VCE. and we fix the operating here we fix the operating point here. We fix the operating point here. It is the midpoint of this. Now this is the value of VCE and this is the value of IC, and this is the point VCE comma IC. Value of VCE comma IC. Here VCE completely depends on IC value. It depends on IC. Okay, our intention is to stabilize the operating point here itself. It cannot move. Need to keep that operating point there itself. Intentionally we are not moving, but due to the different actions involved in the transistor, operating point is not stable at one particular point. It is not always try to move. But our intention is to keep that point stable. Keeping the point stable in this sense, keeping VCE and IC value constant. And VCE value indirectly depends on IC value. So if you maintain a constant collector current, then automatically VCE also going to be a constant. So there is another definition for biasing, that is keep to maintain a constant collector current in active region is called biasing. Okay, now I am writing that. Another definition for biasing. Another definition for biasing. Okay, now that is in terms of IC I am defining this. Keep to maintain a constant collector current in active region. This is in terms of collector current. Now I am defining the same thing in terms of base current. See this, providing proper base current. Here this is the at a different base current we plot it. Some base current we are maintaining. So to providing this minimum base current, to providing this sufficient base current such that to take the transistor into active region, also called a biasing. So to provide a proper base current proper required base current to take the transistor into active region. Into active region. So this is also the another definition for biasing. So with respect to region we defined, with respect to base current we defined, with respect to collector current also we defined. Okay, so now we need stabilization of this operating point. How to maintain that operating point stable? Now we check it. So our intention is finally to maintain constant collector current. So IC should be constant. That is our intention. Should be constant. Should be in, okay, it is operating in active region. In active region IC is constant. Okay, now because in saturation region it is constant, IC maximum. In cutoff region IC minimum. Okay. Now, see, basically we know the equation for IC. IC is beta times IB plus 1 plus beta times IC naught. So that means IC is a function of IC naught comma IB comma and beta. If any one of this is changing, beta value, IB, IC value changing. And another way I am writing is also a function of IC naught I am keeping as usual, but IB is depends on VBE. VBE changing, IB changes. So VBE and beta. So if any one of these parameters is changing, automatically IC value is going to change. Now by using Taylor series, I am going to representing total change in IC by delta IC is dou IC by dou IC naught into delta IC naught plus dou IC by dou VBE into delta VBE plus dou IC by dou beta into delta beta. Okay, like this you can represent the total change in IC. This is the total change in IC. Change in IC. Okay, now I am representing this one in a different form. Now this is represented by a stability factor S. It is represented by a stability factor S dash, and it is represented by a stability factor S double dash. It is represented by S, it is by S dash, it is by S double dash. Now it became total change is S into delta IC naught plus S dash into delta VBE plus S double dash into delta beta. Now here S comma S dash and S double dash are the stability factors. For better circuit, they should be as much low as possible. For better circuit, they are as much low as possible. They should be there as much low as possible. For better circuit, they are as much low as possible, and ideal value is 0. Ideal values are 0. Value is 0. This is the ideal value of stability factor. S dash and S double dash. Anyone you can take. Its ideal value is 0. Ideal value 0 means there is no change in IC naught, no change in VBE, no change in beta. Once all those are constant, no change in those parameters, now automatically IC also going to be a constant. Okay, that is the intention there. Now, so these are the ideal value. Ideal value is 0. Okay, now I am going to defining individual values of S. Okay, here are a few of the top educators from Unacademy. Tiwari Sir, IIT topper, 7 years of GATE and Engineering Service Exam. Ankit Goyal Sir, he obtained All India first rank in GATE Electrical. He was awarded President of India in gold medal at IIT Indore. And Jaspal Singh sir, he is ex-IAS officer, All India 4th rank. Sanchit Jain sir, he is the computer science faculty having experience more than 8 years. Because of these things, we are claiming that our educators are the top educators. Here are few more top educators, and here are few more top educators from different departments. And just I am going to glance what are the different engineering disciplines available: ECE, chemical, mechanical, computer science and IT departments, instrumentation, electrical engineering, civil engineering, and last and but not least, production and industrial engineering. These are the different engineering disciplines available in that. See, there are two subscriptions, Plus Plan and Iconic Plan. In Plus Plan, India's best educators are handling your subjects. Interactive live classes are there, structured courses and PDFs, and live tests and quizzes are there. Same thing here also, but here we are going to show the difference. Once you attempted a test, it was analyzed by your personal coach, and he do the personalized test analysis, prepare a study planner, and proper respect to study material they will provide. By following these two, every student gets success in their examinations. By taking these two, every student is getting success. This is about, these are the available two plans. Now if you check the cost in Plus Plan, it is available in different subscriptions: 1 month, 3 months, 6 months, 1 year, 1.5 year, and 2 year subscriptions. And the beauty is here EMI option also available. And for 1 year subscription, its cost is 30,250 rupees. By using my code VRAW10 during subscription, you get it by 27,225 rupees only. Okay, and there is Iconic Plan. In Iconic Plan, it is available in 2 subscriptions, 1 year and 2 year subscriptions. And here also EMI is available, and for 1 year it is 50,250 rupees. Okay, and by using my code VRAW10 during subscription, you get it by 45,225 rupees. 45,225 rupees by using my code during subscription. So please discuss once with your parents, family members, and faculty who are having knowledge on GATE and engineering service exams. Take a right decision. That decision has to change your life towards beautiful side. Thank you. Now we are moving back to our topic. Now, just before we defined total change in collector current, that is S into delta IC naught plus S dash into delta VBE plus S double dash into delta beta. Now I am writing S is from this delta IC by delta IC naught at a condition of delta VBE equals to delta beta equals to 0. 0. And S dash, that is delta IC by delta VBE. So by keeping delta IC naught equals to delta beta equals to 0, and S double dash by taking delta IC by delta beta by keeping delta IC naught equals to delta VBE equals to 0. See, taking 0 delta change in the sense keeping constant. It means keeping VBE, it means keeping VBE and beta constant. That is the meaning of this. Okay, now see this beta. with respect to beta, with respect to VBE, with respect to IC naught. With respect to these three parameters, your IC is changing. Okay, if you observe this, beta value of a transistor is constant. Once you are taking a transistor, for that transistor beta is constant. It is changing due to three reasons. If you take a beta, by aging effect it will change due to aging, due to temperature, and due to transistor replacement. So I am going to taking the, if I take a new transistor and keeping temperature constant, then there is no effect of this. And if I am doing the experiment with a single transistor, no change in beta. So it is very easy to us to maintain beta value constant. So because of that, I am not going to disturbing this. So the effect of this beta on IC is negligible, very small, very negligible amount it is. And VBE, in case of VBE also, if you take VBE, so VBE is decreasing by, see this, your VBE depends only on temperature. If temperature is increasing, VBE is going to decrease. And for every 1 degree centigrade rise in temperature, VBE decreased by 2.5 millivolts degree centigrade, minus 2.5 millivolts per degree centigrade. Even temperature is increasing 2 degrees centigrade or 4 degrees centigrade, hardly it is a 10 millivolts. 10 millivolts means 0.01 volt. So compared to 0.7 volts, 0.01 is very small. So you can neglect that. So again, the effect of VBE on IC also very small. Now this is the crucial one, IC naught. The effect of IC naught in IC is very high. Now we check it. Now, so you defined S is dou IC by dou IC naught. Here, if you take your IC naught is increasing, it increases if temperature increases. See this, if temperature increases, IC naught increases, and for every 1 degree centigrade increase in temperature, IC naught increased by 7%, and for 10 degrees centigrade increase in temperature, IC naught increased by doubled. This is very important, and it can be calculated by using this relation. IC naught 2 is equal to IC naught 1 into 2 power T2 minus T1 by 10. That is the equation for IC naught 2. And so because of this, we are giving high priority to this. S. Okay, so IC naught, therefore change in IC naught affects more IC. Therefore IC naught, change in IC naught or change IC naught affects more part of IC, So most of the part of IC is affected by IC naught. So that's why I'm going to giving high priority to stability factor S. Now I'm going to deriving an equation for that stability factor. So S is, you are defining that either you can take D or dou IC by IC naught. Okay, now we know IC value. IC is beta into IB plus 1 plus beta into IC naught. Now differentiating this with respect to IC. Differentiating with respect to IC. So this is dou IC by dou AC. 1 it is 1 equal to beta into DIB by DIC plus 1 plus beta into DIC naught by DIC. Just take this one this side. Therefore 1 minus beta into DIB by DIC equal to 1 plus beta into, now I am writing this one is 1 by beta, sorry 1 by stability factor, yes, this part. From this we can write stability factor S is 1 plus beta by 1 minus beta into DIB by DIC. This is the equation for stability factor. See this. Just I taken this part this side and S this side. Then you got this. S is 1 plus beta by 1 minus beta into DIB by DIC. Just by calculate the IB value, and from that IB value get the value of differentiate that with respect to IC, take that value, substitute here, then you get the stability factor. Okay, now so far we know how to get the stability factor and what is stability factor. I think so some of the students having doubt, sir, why are you differentiating this with respect to IC? If you differentiate it with respect to IC naught directly with IC naught, DIC by DIC naught, directly we get the S value. Why are you differentiating like this? See, if I differentiate with respect to IC naught, DIC by DIC naught equal to beta times DIB by DIC naught plus 1 plus beta. But there is no proper relation between IB and IC naught. Because of that, I am not going to differentiating with IC naught. I am differentiating with IC. Only that is the difference. Okay. Now this is the final stability factor. Okay, thank you. Thanks for spending your valuable time with us. And don't forget to use my code VERA10 during subscription. Hit the bell icon and subscribe us. Please give your valuable comments on YouTube. Join our Telegram group for getting latest updates on our upcoming videos. Thank you very much. Once again, I am welcoming you all to this beautiful online learning platform, Unacademy. Thank you very much.